Hello, welcome to Unit 1, Lesson 5, Exploring Transformations of Parent Functions. So yesterday we looked at parent functions of linear, quadratic, absolute, reciprocal, and radical functions. Today we're going to look at what all the letters meant in the transformation generic function that I showed you. Okay, so if we use the notation y equals fx, then the transform function is of the form. Okay, so this is what we were looking at, yes, in that other lesson. The only difference is we're adding the f here. It doesn't make a difference to our work. It's just telling us that everything inside this bracket, so the k bracket x minus d, that represents the x value, okay, the part in the brackets of our function. Okay, so the first variable we're going to look at here is the a, the first transformation. We're going to do this in purple. And the a represents the vertical stretch or compression. Okay, and we've looked at this before in quadratics in grade 10. We're going to touch on it again. If a is larger than 1, the graph is vertically stretched by a factor of a. Okay, so if a is 3, the graph will be vertically stretched by 3. If a is in between 0 and 1, then it is vertically compressed by a factor of a. And if a is less than 0, it is reflected on the x-axis. Mistake. Okay, so it just means everything flips upside down. Okay, the next transformation we're going to look at is the k value. And the k value represents a horizontal stretch or compression. By a factor of k. Okay, this time if k is larger than 1, we say that the graph is horizontally compressed. Okay, so it's the opposite of the vertical stretch or the vertical transformation. This time if k is bigger than 1, it is compressed. And if it is in between 0 and 1, then it is stretched horizontally, again by a factor of k. And if the k value is negative, so less than 0, then it is reflected of the y-axis. So it doesn't flip upside down like it did with the vertical stretch and compression. This time it'll flip from left to right. Okay, our third transformation is D. And that represents a horizontal translation. If D is greater than 1, so that means you see x minus d, because remember in quadratics we worked with whatever was in the bracket, you do the opposite. So if it said negative 4, you move to the right 4. If it said positive 7, you move to the left 7. Okay, so if it looks like this, x minus your d value, you're going to move that many to the right. And if it says x plus d, you're going to move to the left. All right, and then the last transformation we have the c value. That is a vertical translation. This time, because it's not in the brackets, the C comes at the very end. You just do exactly as you see. So if C is greater than 0, you're moving up. If it's less than 0, you're moving down. Okay, invariant point, a point that is unchanged due to transformations. Okay, just definition word, just in case you see it later on. Okay, looking at transformations. So write the transformation that results in the function y equals negative 2f bracket 3x plus 5 and then the c value of plus 6. Okay, so I'm going to just write our generic transformation formula. And what are we going to change it into? Okay, so we have an a value. First off, write our fx equals. So we have an a value of negative 2. Now, the thing with our k value, we can see in the transformation equation, it's k bracket x minus d. And in the function that it's given to us, it's just 3x plus 5. So we have to take out that 3. We have to divide both of these by 3 to get it into the right form. And we're going to get a k value of 3 and a d value of 5 over 3. And then finally, our c value stays unchanged, and it is a plus 6. And sorry, I forgot a bracket in here to close that off. Okay, so again, we have an a value of negative 2, and that's telling us that it's a vertical stretch of 2, and that it's reflected on the x-axis. Okay, we have a k value of 3, and that tells us that there's a horizontal, this time a compression of 3. We have a d value of negative 5 over 3, right? It says positive 5 over 3 in the bracket, so we do the opposite. This is a horizontal translation left of 5/3 units. And finally, the c value is plus 6. That's a vertical translation up of 6 units. Okay, and we're going to use these four transformations for the remainder of the note. So using the transformations above, write the transform function for the following parent functions, and then sketch a graph. Okay, so we are given a radical to begin with. And if we remember yesterday's note, we put the a value, it's the k and the x minus d that goes underneath the root sign, and the 6 stays alone. Good. So if we were to graph this one, okay, we know our parent function with radicals looks like this. Okay, so that is fx equals the root of x. But now we're changing it. So the big thing we need to know, it has a horizontal translation to the left of 5/3. So let's say that's right there. And up 6. So that is going to be your starting point. Okay. It also has a reflection of the x-axis. So this one is not going up and to the right, but it's going down and to the right. And it's stretched out a little bit more because of the a value of 2. So it looks like more like that. Okay, and that's the green one. Okay, down here with a reciprocal. So we have -2 bracket 1 over our 3 x plus 5/3, and then a plus 6. Okay, for this one, I'm not going to draw the parent function. We have it on another note. The big thing we need to know here is the -5/3 is the x asymptote, and the plus 6 is the y asymptote. Okay, so at +6, we're going to have an asymptote. At -5/3, there's going to be another asymptote. So remember, it gets closer and closer to that line, but never actually touches. So it's going to look like this. It'll look like that. Good. And the last point, so if you're given a point from the original function and it's asking for a corresponding point in the new function, then there's a little bit of math to do. So, okay, so if the point 2, -3 is on the original function fx, use the transformations above to determine where that point is in the new function. Okay, and to do this, we need to work with this formula. So you're going to do 1 over k x plus d. That'll give you your x value. And ay plus c. That'll give you the new y value. Okay, so we're just going to start plugging all the information in. So 1 over our k value was 3. Okay, the x value that we now know is 2 that we're transforming. And the d value that we're originally given is -5/3. Okay, so I'm actually going to change that positive to -5/3. On the y side, our a value is -2. The y that we're changing is -3. And our c was +6. Okay, so we end up with 2/3 minus 5/3. and we end up with 6 plus 6. 2/3 minus 5/3 gives us negative 3/3. 6 plus 6 is 12. Negative 3/3 is just the same as negative 1. So therefore that point in the new function will be negative 1, 12. Thank you.